Hi there. Hope you have a fantastic day today. This lesson, I will go through 2023 HSC paper with you. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 20. So to solve for this, first of all, we need to change the domain first because the domain is instead of theta now becomes theta minus 60. So we need to minus 60 on both sides. So 0 minus 60 is negative 60 degrees. And this is theta minus 60 degrees. And 360 minus 60 give me 300. So now the new domain is from negative 60 to 300 degrees. Okay, keep that in mind. So now let me just write down the questions. So that is sine is negative root 3 over 2. Now since sine is negative, so it should be on the third and the fourth quadrant. So let me just draw the diagram out. So this is in the third and the fourth quadrant. So to work for the reference angles, so what we do, we just go inverse sine of root 3 over 2. So if you go inverse sine of root 3 over 2, should be 60 degrees. So that is 60. That is 60 degrees. So therefore, theta minus 60 degrees will equal to, so the domain is negative 60. So if we go backward this way, so the first answer is negative 60 degrees. So that's the first answer. And then we stop there to go clockwise. So now we go anti-clockwise. So the answer is this one from here to here. So 180 degrees, we add another 60 degrees on top. So that will give me 240. So 240 degrees. And we go from here to here is 360. We minus 60, so 300. So the answer is 300 degrees. And we stop there because is the maximum is 300 degrees. So we stop there. So now I just solve for theta. So what I do, I move this 60 degree on this side. So in another word, I plus 60 on each of those. Okay. So therefore, theta equal. So negative 60 plus 60 is 0 degrees. And 240 plus 60 is 300. And 300 plus 60 is 360 degrees. So there you go. Question 21. So first of all, we know that term 4, T4 is equal to 48. And term 8, T8 is give me 3, 1 over 16. So we need to find the possible values for common ratio. That is R. And then the first terms. Okay, so the corresponding first term. So we know the rule is this. So T of n is AR n minus 1. And we know that term 4 is 48. So we just substitute this in. So 48 is equal to AR. So n is 4. So 4 minus 1 is 3. And then when term 8, that is n equal 8. So that's T8 will give me 3 over 16. So that means 3 over 16 will give me AR. And n is 8. So 8 minus 1 is 7. So power 7. So let's name this equation number 1. And this is equations number 2. So what I do, I just use equation number 2. We divide by equation number 1. So just go 3 over 16. And we divide by 48. So there you go, 1 over 256. So 1 over 256 is equal to, so that means AR power 7 divided by AR power 3. Let's write this down. So equation number 2, we divide by equation number 1. So now what I do, I just cancel this. So now this A cancel out. And 7 minus 3 give me 4. So r power 4. So that is 1 over 256 is equal to r power 4. And to find r, which is take 4 roots of 1 over 256. But because it's even roots, so we have to put a plus and then minus. Keep that in mind. So this means r is equal to, so 4 roots, answer. So there you go, a quarter. So that means plus or minus a quarter. So now we need to find the corresponding first term, that is a. So let me just write that on here, okay? So when r is negative a quarter, so this means that we can either substitute on equation number 1 or equation number 2. So let me just substitute that into equation number 1. So that means 48 is equal to a negative a quarter power 3. So therefore, a is 48 divided by bracket negative 1 over 4 power 3. So there you go, 3072, but it's negative. So negative 3072. That is when r is equal to negative a quarter. So when r is a quarter, so this means that 48a times 1 and a quarter power 3. So therefore, a is, so 48 divided by 1 over 4 power 3. So there you go. So 3072. So therefore, r is negative a quarter, a is negative 3072. So r is a quarter, a is 3072. So there you go. Question 32. So to work out the angle AEM, so let me just label this. AEM is this angle here. Let's just put this theta. Now to work this out, first of all, we need to identify the triangle first. So we have this edge here and this edge. So therefore, we need to work out this edge, the length of this, okay? So we know that M is the midpoint and the side of DC is 6. So therefore, this must be 3 and 3. So we can find AM. To work out AM, so we need to focus on this triangle here. It's a right angle triangle here. So therefore, to find AM, I use Pythagoras theorem. So let me just move this up a bit. So we have AM square is equal to 7 square. We add 3 square because we need to work out the hypotenuse. So just go 7 square plus 3 square is equal to 58. So therefore, AM is square root of that. So let me just put in exact form for now, okay? Square root of 58. Now this is square root of 58. So now to work out the angle theta, we focus on triangle AME. And you know that this is a right angle triangle. Keep that in mind. So according to this angle here, so this is adjacent and this is opposite. So we have opposite over adjacent, so we use tan, okay? So now we just go tan of angle theta is opposite, which is square root of 58 over adjacent, that is 8. So now theta is equal to tan inverse square root of 58 over 8. So that will give me, so square root answer and just divide by 8 and we just go inverse 10 answer. So there you go, 43.59 and so on. So we need to round up to the nearest degree. So 44 degrees. 44 degrees. So therefore, angle IEM is 44 degrees. So there you go. Question 23. So first of all, we know that the mean of the koalas is 10.40 kilograms. And the standard deviations is 1.15 kilograms. And the question is, how many would be expected to weigh more than 11.93 kilograms in a group of 400 adult koalas? So to work this out, first of all, the information is given. The table here is given the Z, probability of Z less than a number, okay, a positive number. For example, if it have probability of Z less than, let's say 1.37, so that means less than 1.37, this is 1.37 for examples, and it's given in here, okay, so that is give me 0.9147. But then the question is, we need to find the probability that is greater than 11.93 kilograms. Let me just write this down. So the probability of X, because it's X, okay, greater than 11.93 kilograms. Now to work this out, so we need to convert to Z score first, okay? So to convert Z score, so let me just write it down here. So we know that Z is equal to X minus the mean over the standard deviations. And we know that X is 11.93. So 11.93, we minus the mean. The mean is this one here, 10.40 over the standard deviation. And the standard deviation is 1.15. So that will give me 11.93, we minus 10.4, and then we divide by 1.15. So 1.330 and so on, just correct to 2 decimal place because the table gives us up to 2 decimal place. So that is 1.33. Now we know that the probability of X greater than 11.93 kilograms is exactly the same as probability of Z greater than 1.33. But the table only gives us less than, not greater than. So therefore, the probability of Z greater than 1.33 is exactly the same as 1 minus the probability of Z less than 1.33. Because the probability of Z greater than 1.33 plus the Z less than 1.33, so that is equal to 1. So now what we do, we just look at the chart. The probability of Z less than 1.33 is 0.9082. So equal 1 minus 0.9082. So that is equal to, so just go 1 minus 0.9082. So there you go, 0.0918. So 0.0918. So therefore, the probability of Z greater than 11.93 kilograms is 0.0918. Then to work out the expected number of koalas that greater than 11.93 kilograms out of this group here, that is 400. So we just go 400, we times the probability. So 0.0918. So that will give me, so just go answer times 400. So 36.72. But because of number of koalas, so we just have to write in whole number. So the answer is 36 koalas. So there you go. So therefore, so 36 koalas. Question 24. So given that the area of the garden is 50 square meters, and we need to show that the value of y is this. So to do this, we just need to find the area of the garden. Now, before we do that, of course, we know that the x values is from here to here, and the gap is 1 unit on both sides. So therefore, the length of the garden is x minus 1 on the left and 1 on the right. So instead of 1 minus 1, we minus 2. So the length of this is x minus 2. And the width of this is y. And therefore, to find out the width of the garden is y minus this gap here. And this gap here is 1. So y minus 1. So there you go. And we know that the area of this is x minus y times x minus 1 is 50. So let me just write this down. So that means x minus 2 times y minus 1 is equal to 50. So now what I do, I just divide it by x minus 2 on both sides. So I divide this, x minus 2, x minus 2. So that cancel out. So therefore, y minus 1 is 50 over x minus 2. And I move the 1 on this side, become plus. So therefore, y is 50 over x minus 2. We add 1. So there you go. Part B. So we need to find the value of x that gives us the minimum area of the path. Okay. And we need to show it is minimum. So first of all, to work out the area of the path, so this is the area. That's what we need to work out. So to work this out, so we just work out the area of the larger rectangle and we minus area of the garden. That is minus 50. So area of the rectangle is y times x. So let me just write this down. So A is xy, because y times x is x times y, is the same, and minus the area of the garden, that is 50. And we know that y is this value here. So 50 over x minus 2 plus 1. So that will give me x times 50 over x minus 2 plus 1. Of course, we need to bracket and minus 50. So what I do, I just expand the brackets. So that give me 50 x over x minus 2 plus x minus 50. So there you go. To work out the minimum area, we differentiate first and we solve for x by the a dx equal to 0. So to differentiate this, so dA dx will give me, we use quotient rule for this. So differentiate the top, that give me 50. And then we times the bottom, x minus 2. And we minus, differentiate the bottom functions, which is differentiate x minus 2, give me 1. And we times the top functions. And then over x minus 2 all square. And then we differentiate x, it give me 1. So we add 1. And differentiate 50, give me 0. So now what I do, I expand, I simplify. So this time that, give me 50x. This time that, give me negative 100. So let me just write this down. So equal 50 x minus 100. And then we minus 50x over x minus 2 all square, we add 1. So now what I do, I simplify this. So this cancel out. So will give me negative 100 over x minus 2 square plus 1. So that will give me negative 100 over x minus 2 all square plus 1. So dA dx is equal to 0. So dA dx is 0. So this means that negative 100 over x minus 2 square plus 1 is 0. To solve for this, so I just move the negative 100 over x minus 2 square on the other side. So that will give me this. Okay, this is exactly the same as 1 equal 100 over x minus 2 all square. And I times x minus 2 all square on both sides. So this will give me like this. X minus 2 all square is 100. And I take square root on both sides. So that means x minus 2 equal plus or minus 10. But then we're dealing with length. Okay, so therefore we should have a positive answer, not a negative. So I can ignore the negative 10. So then what I do, I move the 2 on that side. So that becomes 10 plus 2. So that means x is equal to 12. So now we need to test it. So when x is equal to 12, so that means, let's say x, and this is 12 here, the left hand side of 12, let's say 11.5. And the right hand side of 12 is 12.5. So this is the IDX. So at 12, we know that is equal to 0. So let me just draw out the table first. Now I just need to substitute the x value into the gradient functions. That is this function here. Okay, so I just go negative fractions 100 brackets 11.5 minus 2 close bracket square at 1. So that is negative 0.11 or negative 0.1 we do. And when x is 12.5, I'm just going to change the value to 12.5. So 12.5. So there you go. So 0.1 we do. So 0.1. So we have a negative gradient, 0 gradient, positive gradient. So therefore, minimum area at x is equal to 12 meters. So there you go. Thank you so much for watching. Bye.